a long time, guys. I'm going to say we're done here, but not 9.5 is your title. So we're learning some new log properties today, and the purpose of these log properties is to help us with taking a complicated looking log expression and crunching it down into something simpler, really. But you can also use them to take something simple and expand it out. That usually doesn't have much of an application other than just helping you get used to the properties. But the thing about where we can crunch it down, that actually helps later on when we get to solving equations and stuff. So that's what we'll be doing. All right, let's go ahead and begin here. So part A, log properties. Part 2. Yes, Jonathan, what's up? Sure. Okay, now, guys, I'm going to write two sides here. You don't need to write the stuff on the left side of the board. I'm just writing that to help you understand what's going to be on the right side of the board, okay? Now, you don't need to write the stuff on the left side. So, if I have a to the x times a to the y, what do you do with the exponents there? Actually, you would add them. Kind of like if you had x squared times x to the third power, right? That would be x to the fifth. You would add those powers together, right? There's a log property that's like that, okay? So, let's see. If you have two logs that are being added together, like log base a of m plus log base a of n, you could put those together as one log if you multiplied the m and the n together. Okay? Now, I'm not going to prove these properties to you. I'm just going to say these work and we're going to use them. There's somebody proved that actually works, but we're going to just take them at face value for now. This is a multiplication sign. Yeah, that's a multiplication sign. So, just like addition is related to multiplication with exponentials, a similar rule kind of applies with logs. Multiplication is related to addition. And the reason why I'm making this connection for you guys is to show you that
it's minus n?
It's supposed to help you guys remember it a little bit based on what you know about exponentials. Because the reason these properties work over here is because logs and exponents are inverses of each other, so they're going to share some similar properties. Did you have a question?
Yeah.
No, that's m times n.
Oh.
All right, now how about this? What if I gave you guys another one here? What if I said a to the x divided by a to the y? What would that be equal to? A to the x minus y, right? So we have a similar property for logs then as well, all right? So if just like subtraction is related to division with exponents, we have a similar rule for logs. If you have log base a of m and it's being subtracted by log base a of n, then we can write that as one log where the m is being divided by the n. All right, the last one I want to share with you guys for today. If I have a to the x and you raise that to the y power, what do you do with your exponents there? You multiply them, a times y, right? So just like powers are related to multiplication, similar thing, this one's a little bit weirder, but a similar thing applies to logarithms. If you have a number that's multiplying your log, like let's say x times log base a of m, we could rewrite that as log base A of m to the power of x. Okay? So these are our three properties we're going to use for the day. I'll call them 1, 2, and 3. So today I might ask a question, what property is this? And you guys can just say rule 1 or something like that, okay? So that's, I'm going to number them 1, 2, and 3. But there you guys have it. Log properties kind of are related to exponent properties. Multiplication becomes addition. Multiplication is related to addition. Division is related to subtraction. Division is related to subtraction. Powers are related to multiplication. Powers are related to multiplication. So there's that. So next one. So for those of you guys watching the video, I accidentally forgot to record one, but there it is. Let's go ahead and take a look at a second problem here. How about number 2? Log base 3 of x squared minus log base 3 of x.
So wait, we're not using ln anymore?
We will. I'll probably throw 1 or 2 in today. So what rule do we have here?
2.
Rule 2. So according to rule 2, 2 logs that are being subtracted could be written as 1 log where the arguments are being what? Divided. Now, here's the thing about that rule. Just like with subtraction and division, the order matters, you know. So with addition and multiplication, it doesn't matter. But with subtraction and division, it matters. The one that comes first is the one that has to go on top, and the one that comes second is the one that goes on bottom. We can simplify that, can't we?
Yeah,
So let's go ahead and simplify it. X squared over x is, like you guys said, just x. Okay? I'm going to be just doing a bunch of examples because there's a lot of the little details that can come up. But so hang in there. Let's see. We have, how about this? 5 log base A of 2. Let's just do that for now. 5 log base A of 2. So right now we only have 1 log, but we can use a property here. What property does this look like? It looks like rule 3. Rule 3 says whatever number you're multiplying by in the front, you can make that an exponent on your argument. So it can look like this, log base A of 2 to the 5th power, which we can simplify, by the way. 2 to the 5th power. Anybody? Good job. 32. So those are like the basic problems. They're very straightforward. I'll throw in a few other weird things now that you might see along the way. Let's take a look at weird thing number 1 here. How about this? Log base A of x over 2. Log base A of x over 2. All right, so, yeah. Excuse me? Yeah, I think so. So first of all, let's rewrite this. Let me kind of take a side moment here. 5 over 2. Isn't that the same thing as 1/2 times 5? Right? It is. So in this case, what I'm going to do then is I don't like the way that this one is written. So what I'm going to do is I'm going to change it a little bit so it fits our properties a little bit. Instead of saying log base a of x over 2, I'm going to rewrite it like this. It's the same thing. But now that I've rewritten it like that, what property are we looking at? Rule 3, right? And according to Rule 3, we could take this thing and put it on the x, right? Now, there's nothing wrong with this answer, but if you want to raise your hand and tell me for bonus point, how else can we write this answer? I'll give you a bonus point. Go ahead. It's the square root of x, right? Log base a of the square root of x. Because, remember, a half power, that means we have x to the first power with a square root on it. Okay? So that's weird thing number 1. What else could I throw at you? It's a little bit weird. How about ln? I'm going to give you 2 weird things in this next one here. How about ln of 3 ln of x plus 2 ln of x? All right. So, first of all, what? It's just another log. Yeah, it just means log base e, right? So it doesn't affect anything we're doing today. The properties are all the same. So, what rules do you guys see here? Because there's actually 2 rules in this one. It's the first and the third. All right. So we have Rule 3 is there, right? And according to Rule 3, we're going to take these and we're going to make them exponents, right? And now we can do Rule 1. So if I did Rule 1, it would be ln of what? The plus sign is what makes it Rule 1. So now according to Rule 1, you have the right idea. I'm going to write this step here, though, real quick. You're going to multiply those, right? But it's not x to the 6th. Yeah, that's an exponent rule. It's 5. I'm not too worried about that rule. I would like you to know that, obviously, but you know, that's an old thing. So, all right, I'm going to throw one more problem at you, and then I'm going to let you guys practice, okay? One more, and then I'll let you practice. And this one's kind of like worst case scenario. Where are we? Number 6. So let's say I gave you guys log base 2 of x over 3 plus log base 2 of y, and I'll put a 3 here. I don't like how I wrote that. Fix that. And then minus log base 2 of z. That's the spirit. So on everything we discussed, what are some things that you guys see that we can do here? Okay. So we're getting the suggestion to do this here, and I agree. I think that's a good start. That's not a log property, but that's something I told you that we want to do when they put it over a number like that. Okay, good, Oz. What else do we see here that we can do? That's right. So we're going to apply Rule 3 here. I can take this and make it a power. I can take this and make it a power. So I have log base 2 of x to the 1/3 plus log base 2 of y to the 3rd power. And this is a 2, by the way. My 2's and z's look the same, but I'm putting a line through my z's so you guys know which one it is. When Eric gets back, yeah. All right, so what else can we do here? We could turn the x to the 1/3 into a cube, can't we? A cube root. So let's do that. And you don't have to show every step. If you can do a lot of this stuff in your head, I don't mind. But for teaching purposes and notes, it might be nice to have every step. So what I just did here was I turned the 1/3 power into a cube root of x instead. So we're just doing basically what this problem has is everything we just did in one problem, really. What else do we see we can do here?
You can put the y. No, you can't.
So remember, my goal is to get just one log, right? I've got 3. What do you got, Mike?
Can you add the y3 to the cube?
We're going to combine these two. So how would I put these two together? What rule is that? That's rule 1. So if I were to put those together, what would I do? I would write 1 log, right? And what would I put it next to it now?
Cube root of x
Cube root of x,
plus y
not plus though,
times
times y cubed, right? Because we multiply them. And bring this other guy down, right? We haven't done anything with that yet. Do I have 1 logarithm yet? No. So how can I get these two to be combined? Cancel? No. Not rule 1. Rule 2, right? And it's dividing. It's dividing. You're right. All right, so rule 2 says that we take this log here, the cube root of x and the y cubed, and we put those on top and we put that one on the bottom. So that was a crazy problem, but we are officially done.
But you're not going to do this test,
I don't see why
I don't think I should get a lot of these.
Right.
Have too much work.
not doing it.
Wait, do you think we can pass on home?
Wait, do you want school to do this?
Yeah.
I'm down. I'll take a vacation so long as I get paid for it. All right. If I don't get paid, I'll come get you guys from your house with Ebola and the corona. I'm like, get in my car. Daddy's got to bring home the bacon. I don't know why my examples were weird and creepy like that, but there it is. Guess it's just who I am.
Can't you get in trouble for coming to our house?
Well, they shouldn't give me your addresses then.
We don't.
What is this?
This is for you.
Is it practice?
Yeah.
Well,
We're
there's
gonna-
like 2.
We're going to start easy, and we're going to work our way up.
Okay, is there anything else writing after this?
Huh?
Is there anything else writing after this?
Yes, sir.
I'm getting dizzy.
I can come over and see it for a second and show you what you missed. I don't want to have other people fall off the wagon here. Okay, there you go. 5 problems for you. Show me what you got.
But then y stay negative.
Oh, wait.
No, it's not negative. It just goes to the bottom. All right, guys, so I'm going to put the answers up here real quick for you to check your work. Number 1, you should have gotten ln of 6. Now, number 2, I would assume a lot of you guys probably got this. And there's nothing wrong with that, but a better answer would just be to say that, because the square root of 4 we know, right? As for this one, it's log base A of 3, 12 divided by 4. As for this one, you would put this here, you would put this here, and then because of rule 2, you would divide those. So there's your final answer for that one. Now number 5 is a little bit more quirky, so here we go. First of all, the 3 goes here because of our third rule, right?
Could you actually do this one?
Okay, I just did that, so follow along with me. So the 3 goes there because of rule 3. As for this one, these two, what rule is that? That's rule 2. And according to rule 2, which one goes on top? X cubed goes on top and y goes on the bottom. But we still have that plus z over there, right? And now, according to rule 1, we would multiply this times z. Now, if you guys think of this as z over 1, this might help a little bit. If you multiply z over 1 times x cubed over y, where's the z going to go? Yeah. Now, some of you guys probably wrote it like this. Log x cubed over y times z. That is not wrong. That's not wrong. However, if you did write it like that, I just want to caution you, that's not what it will look like on the test as multiple choice. They'll have this instead. So my advice would be to write it this way, because that's what it'll look like. That's it. All right. Yeah. All right, guys, I want to show you one more type situation here. And that would be going backwards. Yeah. You refuse. Okay. Expand each expression. Expand each expression using our log rules. So, here we go. Number 1. Log of x squared y. Log of x squared y. Okay, so guys, I have two things being multiplied together here. What rule? Now, when you're looking at it this time, you got to look at the other side. Let me back up a little bit. When you're looking at this, which of these involves two things being multiplied? 1, 2, or 3? 1. So that's a rule 1 there that we're looking at. It's just we're starting on the other side. So the first thing we're going to do is split that up into two separate logs that are being what? Added. Now, what goes here then? And that's a really long G there. That's interesting. All right. So there's that. Now, one of these is another rule. Do you guys see it? According to rule 3, what am I going to do with that? Put it in the front. So we're just going backwards from what we just did. That's all. This will be the last set we're working on. All right, let's do another one here. All right, now check this out. Sorry. All right. Now, I don't like this. I like to keep it a little bit simpler, but there are a few questions like this on the homework, so I want you guys to be prepared for it. So here's the deal with this. What rules do you guys see here that we can maybe use? 2's in there, right? That fraction. What else is in there? The 3, because we have powers, right? And those powers are going to go to the front. Now, there's different ways to handle this problem, but I'd say the easiest way is the following way. I would, yes, distribute this power into your powers first. So I would start by doing that. That's your easiest approach. So that's going to become x to the 6th, and this is going to become y squared. That's your easiest approach. So 3 times 2 is 6, and 2 times 1 is 2. Now, after you've done that, according to Rule 2, I can write this as 2 separate logs that are being what? Subtracted, because division is subtraction, right? Now, which one comes first, though, because the order does matter. The one on top comes first. The other one comes next.
But then you can rewrite that second.
You can still rewrite it, right?
It'll be, can I say it?
Sure, what rule is it, though, first, John?
Rule 3.
Rule 3.
It'll be 6 log x minus 2 log y.
Any questions about this one before we move on to one more type of problem here? Sure. Okay. Let's take a look at a third problem. I'll probably make this my last one here. Number 3. Log
7.
log of, let me back up here a little bit. Z squared x y.
Okay, what?
The square root's the irritating thing, right? So, but what do we do with that? If we don't like the square root, we could change it.
Into a fraction again.
What kind of fraction is that going to be? That's a half power, right? So we have z squared, and instead of the square root of xy, I'm going to write it like this. This maybe looks a little more familiar. What do you guys think now?
Rule 3 to get rid of the...
So here's why you don't want to do rule 3 first.
You're going to do that last because you have a fraction.
So here's why you don't want to do rule 3 first. Rule 3 has a thing where you put the power in the front, right? But the problem is I've got 2 different powers there. So before you can do that, you need to split it, right? But before I even do that, I'm going to distribute again. You guys see how there's 2 letters here, both with a power? So I'm going to put it on both separately. I just want all of those to be apart. I don't want them sharing anything. So, because our goal here is we want to break them apart. So that's an x to the half, and that's a y to the half, right? You guys good with that? The first one is a z, and that's a power of 2, which I'm not being consistent in how I write my 2's. All right, so now, uh-oh, that was interesting. I have no idea what just happened. That was really weird. There it is. Whew. That was weird. Okay, yeah, so we have 3 things being multiplied together. I can write all of those as separate logs, can't I? Log, 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 and all of those logs are going to be being what?
Added.
Because they're all what? Multiplication. If one of them was a division, if you had a fraction, that one would be a minus. But if they're all multiplication, it's plus. So it's going to be z squared here, x to the half here, and y to the half here. Now what do I do? Rule 3, 2 goes in the front. How about here? Half to the front.
Mr. Bailey, what does that be? Log of x over 2?
You're right. And once again, you don't have to show every step, but I am just for teaching purposes, and you might want it for your notes. But you're right. I mean, if you could jump right to the end, then you can. I'm okay with that. So these come to the front, right, because of Rule 3. But as Jonathan was just saying, how is that going to look on your test, though?
That would be log x over 2.
they're going to write it like log x over 2. They're going to write them like that. Just so you know. And there we are officially done with that problem. Okay? So that was a toughie. Student practice, and then we'll be done.
Wait, can you go back up a little bit? Yeah, right there.
Okay. All right. I think that's probably good enough. We'll stop there. What you guys can do. Set. You always do set.
So is this student practice or something?
I can't get any more paper. I'm not sharing my pictures. Hmm?
Is this student practice?
Canny. No, that's not a base. They're all. I just made them all base 10 except the last one, which is base E. I just kind of got sick of writing bases, so I just made them all base 10. Chris was asking if this is a log base A. You guys, it's not. It's a. This is 10. The base 10. But remember, with common logs, you don't write the base, so the A is not the base.